So I mentioned before we're going to talk about transformation up, down, left, right, reflection across the y-axis, reflection across the x-axis, and dilation, vertical and horizontal, stretch or compress. So here I wrote two sine general function, a sine of bx plus c plus d, and negative sine, negative a sine of negative bx minus c minus d. So the only difference is this one's positive on the left and this one's negative on the right. So if you're given a function similar to a sine of bx plus c plus d, now the transformation would apply to cosine also. So your a value would be the vertical dilation, meaning vertical stretch or vertical compress. Your b value is your horizontal dilation, same thing, horizontal stretch or horizontal compress. Now if I'm using exactly what I see, a positive c, then it shifts to the left, and plus d, so positive d would be shift up. Now if we move on to negative a sine of negative bx minus c minus d. So again, a is the same thing, vertical dilation, stretch or compress. B is the horizontal dilation, also horizontal stretch or horizontal compress. Now if I see exactly what I have, so negative c, it means shifts to the right. Negative d shifts down. Negative a, so if your a value is negative, it means reflected across the x-axis. If your b value is negative, reflected across the y-axis. That's all we basically have to memorize for transformation. So this part exactly is very similar to the first one, but since there's negative on the a and the b, there's reflections. So we have to take that in account in the event we have either a or b negative. Alright, before we can go into identifying transformation, there's something I need to cover with dilation. Now again, a, if you have an a value, then you have a vertical dilation. So again, vertical dilation, you have either a vertical stretch or a vertical compress. Now, when the absolute value of a is greater than 1, it's going to be a stretch. So a vertical stretch. Now examples of what a stretch is when the absolute value of a is like 4. That's a whole number. Now if you have a fraction, so the absolute value of a is 5 over 2, which is equivalent to 2.5. 5 over 2 or 2.5, that's more than 1, so that's going to be a vertical stretch. Now if you have a decimal a value from the beginning, such as the absolute value of a equals to 3.1, 3.1 is greater than 1.0, which is the same as 1. If that is true, then it's also a vertical stretch. So regardless if it's a whole number or a fraction or a decimal, if it's greater than 1, it's going to be a vertical stretch. Now vertical compress is if the absolute value a is between 0 and 1. So for example, if you're given a decimal from the beginning, such as the absolute value of a is 0.7, it's going to be a vertical compress. If you were given a fraction, such as the absolute value is equal to 2 over 3, or 2/3, which is equivalent to 0.66, then it's between 0 and 1, it will be also a vertical compress. So again, if the absolute value of a is between 0 and 1, regardless if it's a decimal or a fraction, then it's going to be a vertical compress. Alright, so now we're going to talk about horizontal dilation, horizontal stretch, and horizontal compress. I'm using the same examples as before for A. Alright, so now I'm going to go over horizontal dilation, horizontal stretch, and horizontal compress. Now, I'm using the same number examples, but the only difference is now we're going to talk about the absolute value of B's. So if the absolute value of B is greater than 1, then it's compressed. If the absolute value of B is between 0 and 1, then it's a stretch. So if you recall from vertical dilation, it's basically the opposite now. So to review, if your absolute value b is a whole number more than 1, such as 4, or if the absolute value b is 5 over 2, which is equivalent to 2.5, which is more than 1, if the absolute value of b is a decimal, such as 3.1, which is also more than 1, then it's going to be a horizontal compress. For horizontal dilation, horizontal stretch, if the absolute value of b was a decimal in the beginning, such as 0.7, or if the absolute value of b was a fraction from the beginning, such as 2 over 3, which is equivalent to 0.66, if it's between 0 and 1, it's going to be a horizontal stretch. So you have to keep that in mind. So there's 4 dilation: vertical stretch, vertical compress, horizontal stretch, and horizontal compress. So what I memorize is that A is vertical, B is horizontal, and they're basically the opposite of the definition. So here, horizontal compress and horizontal stretch, I typically remember that, alright, again, vertical is A, and then we switch to 2. So switch to compress and stretch to do vertical dilation, and then vice versa. Switch out stretch and compress to do horizontal. Alright, so we have example 1 where y equals 1/2 of sine of negative 5 theta over 3 plus pi over 2 plus 4. Now, I already underlined our A, B, C, D, and then wrote our A, B, C, D values. So A is 1/2, B is negative 5 over 3. Now C, I took the opposite sign, so C is negative pi over 2, and then D is 4. Alright, since we have an A value, let's take the absolute value of A. So the absolute value of A is 1/2. So I took the absolute value of 1/2, which is just 1/2. Since we have an A value, it's going to be a vertical dilation. Since our A value, or the absolute value of A, is 1/2, which is equivalent to 0.5, meaning that it's between 0 and 1, so this is going to be a vertical compress. Again, regardless if it's a fraction or a decimal, since it's between 0 and 1, it's going to be vertical compress. Now let's talk about the B value. If we do the absolute value of B, which is a positive 5 over 3, 5 over 3 is equivalent to 1.66. Since we have a B value, it's a horizontal dilation. Since the B value is greater than 1, in this case, more than 1.66 is more than 1, this will be a horizontal compress. So there's our 2 dilations. Now, let's talk about our C value. Since C is negative, meaning that when I pull it out and route out the C value, then it's going to shift pi over 2. Since C is negative, this is going to shift pi over 2 left. So it's going to move pi over 2 units to the left. So if this was a whole number and C was negative, so for example, if C was equal to negative 5, then it would say shift 5 left. Now D is positive, then shift 4 up. So it moved 4 units upward. Alright, so that's basically the dilation and the translation. Now, we're not finished, we're almost, but we have to take a look at the b value. B is negative. Since B is negative, it's going to be a reflection Now, since the negative is on the B value, its reflection across the y-axis. So, if our B is negative, if there's a negative sign on the B value, just like that one right there, then it's going to be reflection across the y-axis. So, here's our transformation. You have an A value that was between 0 and 1, so vertical compress. We have a B value, even though it's a fraction, it was more than 1, a horizontal compress. Since our C value, this one right here, was negative, so it shift pi over 2 units to the left. Since D was positive, it shift 4 units upward. And since there was a negative on the B value, reflection across the y-axis. So those are transformations. So in this case, we have 5 transformations here. In our second example, we have y equals negative 7/4 cosine of 3x over 4 minus 6 minus 2. Now, the difference is we have a cosine function, and now we have a whole number instead of radians. So let's take a look at our ABCD. Now, I already underlined our ABCD values and then wrote out the values for those. So A is negative 7 over 4. B is just 3 over 4. C, I did the opposite sign, so since it's minus 6, I use C is equal to positive 6. And then D is negative 2. Alright, so let's take a look at our A value. When we do the absolute value of A, which is just simply positive 7 over 4, 7 over 4 is equivalent to 1.75. Now, since this fraction is more than 1, and when we did the decimal value, it's showing that 1.75 is greater than 1. Same thing as saying greater than 1.00. Since we have an A value, it's a vertical dilation. Since our A value is more than 1, it's going to be a vertical stretch. Now let's talk about the B value. When we do the absolute value of B, it's 3 over 4. Now, what's equivalent is 0.75. Since we have a B value, it's a horizontal dilation. Since our B value, even though it was a fraction, the equivalent, the decimal equivalent is 0.75. That's between 0 and 1. Since it's between 0 and 1, it's going to be a horizontal stretch. So similar to the last example, we had vertical and horizontal compress. In this one, we had vertical and horizontal stretch. Again, it will not always be just like the examples here. Again, as I was saying, if your A value is more than 1, it's going to be a stretch for vertical. If your B value is between 0 and 1, it's going to be a stretch for horizontal. So keep that in mind. Alright, so let's take a look at the C value. Since C is positive, so after you write down the C value and took the opposite sign, since it's positive, shift 6 units right. Units to the right. So since C is positive, after I pull out the C value and took the opposite sign, since it's positive, it shifts 6 units to the right. Now D, since D is negative, then it shifts 2 units down. Alright, now we're almost done. But to keep in mind, once we identify dilation and translation, we have to check if there's a reflection. In this case, there's a negative on the A. So, A is negative. So when A is negative, it means reflection across x-axis. So when there's a negative on the A value, and for this example, then it's going to be a reflection. So again, if there's a negative, either on A and B is a reflection, but A was the only one that's negative, so it's going to reflect across x-axis. So in this example, we have, just like the last one, 5 transformation. The first one, we have an A value, so it's a vertical dilation. Since it's more than 1, it's going to be a vertical stretch. Since we have a B value, so it's going to be a horizontal dilation. Since the B value was between 0 and 1, it's going to be a horizontal stretch. Since C, when we pull out the C value and take the opposite, since C was positive, it shifts 6 units to the right. Since D is negative, then it means shift 2 units down. Since A was negative, it's going to be a reflection across the x-axis. So here are our 5 transformations.